So I have a small example for a compilation stages that uses some basic example. Yeah, when you take C, right, remember there are only 4 stages actually: pre-processing, compilation, assembly, and linking. Okay, so the code which you've written will pass through each and every stage before it converting into a binary. Okay, so the 4 steps needed. Let me show on step number 1. You have been seen, right, a hash include or a macros. Macros, I mean a hash defined one. Maybe, I don't know whether you have already have on that, but so these things, right, these things will be, you can see in the top of the program, right? For example, if you take this one, right, I have included a library called hash include iostream.h or chrono for time, right? These are the pre-processing directives. So when doing pre-processing, right, it will expand it. So for human readable format, we are copying, we are developing a code and we are storing it under iostream.h file, right? So these things will be expanded actually as a single program, as a single file. That's what the pre-processing will do. And it will expand the macros. If you have any hash defines, right, during pre-processing, it will read that hash define and replace it in the code. Maybe I will show you that example too. And the second stage is a compilation. Okay, so the input for compilation is the pre-processing stage. So what is the output of pre-processing? It will be a .i file. Okay, that I file will be fed into a compilation stage. So here the code will compile. It will check for any errors. Okay, remember it during your first stage, right? Even though you have any errors, the compiler will not find it because it is just a pre-processing stage, just an expansion of the header files and macros. When you come to second stage, right, then it will direct the compilation things actually. Okay, that output is called .s file. Okay, that compilation's output will be given to a third stage. It's called assembly stage. Okay, then again, once assembly stage is completed, it will create a .o file, the object file. Okay, so the last stage is linking stage. It will take the object file, okay, convert it into a EXE program, that is executable program. That's what you will execute it on the memory. Okay, and these are the 4 stages will be happening when you compile a C programming. Let me show you each and every stage separately with a small example. So I have a coding small program for each and every stage. And if you take this one, right, one with this code. Yeah, so this is a small program and this is the macro. I told, right, pre-processing macro that will happen in pre-process stage. Okay, and this is a header file. Let me run this command. Okay, how this behaves. So here, if you see at line number 6, right, I am using a value macro here, right? Instead of 10, right, I'm using value here. Then it gets assigned to X, right? So let me execute the pre-processing stage, how it behaves. Now I have a command line here. Sorry. CLR, I guess. Okay. Yeah, so let me run the first command. What is the command for pre-processing? We should use -e, right? So G++ is the compiler name to trigger a C++ compiler, and -e, I am telling the compiler that don't don't execute all the build steps, execute only a pre-processing steps. Okay. After E, I am giving a file name called one_preprocessing.cpp, and I am storing it under file.i. File.i. Okay. If I try to run it, there is a file generated here, right? File.i. Let me open that. If you see that hash include, right, which we have here, that is expanded like this actually. Okay, something is stopping me. Yeah, okay. So, if you see, this is our small program. After pre-processing, if you see, the number of lines is 35,185 lines it pre-processed. Okay, that means this header file has been expanded here. And below that, we have our program. Right, so what just happened is the code before main, right, is completely on, except this completely on iostream library. Okay, so this file pre-processing expanded this as a single file. Okay, even though you had a 10 header files here, it will expand it into a single file that is called .i file. And if you see at line number 31, this one, right, our original code, we have a value, but the pre-processed form have a 10. So what just happened is it replaced this value, this macro, with the 10, the defined value. That's what happened in pre-processing stage. So, and this is the reason we use as a header file. I mean, we are using hash include. We cannot type each and every time this 35,000 lines of code for all these small programs, right? It's not a good idea to do that. That's why the developers have been copied this code, created another file called iostream, and they pasted there. We just use this file. So inside this, these things will be there. Yeah, so that's how. If you see, we have a cout here, right? Even that also defined in this iostream library. If you search it here for a cout, you can find it somewhere. Yeah, here. So this is the part of the header file. Okay, so let me go to next stage. The next stage is compilation, right? So the command for that stage is, what is the input for this compilation stage? The pre-processing stage, right? So let me take this file, file.i, compiling stage. What macro should I use? I should use yes. Okay. Then just enter. If you see, there's one file created called file.s. Right? Now let me open this one. Yeah, so this is assembly language that is created from pre-processing stage. So right now we are, we have executed it pre-processing, then we have it to compilation stage. The output for compilation stage is assembly code, which you are seeing here. This is not a user-friendly format. It's a low-level language still, but still the same logic will be used here. Okay, this is assembly code that's generated as a part of a compilation stage. So now we move to next stage that is called assembly stage, and that uses a command called -c. Okay, let me go to the command prompt again. So now the input for this is not I, because we already pre-processed and we generated assembly code. So the input for third stage is yes. Okay, and we can use -c for that for next stage. Yeah, now see the file created called .o. Right, this is the object code actually. So right now we are in assembly stage. Okay. So if you try to open the object code, right, you don't read it properly because it's not a human readable format. It's a completely a hardware, the machine code actually. Okay, even though you can read assembly language code, .s file, but it's hard to interpret this .o code. Okay, so the final output, we still need exe, right, to execute. These are the three stages of iOS, right, we cannot execute. Okay, to execute it, we need a exe file, right? To do that, we need the help of a fourth stage called linking stage. Okay, this is where you will get the exact exe to execute. Okay, so command for that is g++. Let me give a file name called. So the input here is file.o, right? The object file. And I'm giving hi-show, and I'm giving my executable a name called cpp test. This you can give any name, and if you try to enter it, then you can see a exe here with the name you given here. right? Now it's an executable one. If you double click it, it will execute. So to generate a binary code, right, the machine needs to undergo this much stages: pre-processing, compilation, assembly, and linking. Finally, we have executable here. So this is what happening when you try to build a code, actually, right? So the compiler will internally do this all the steps without asking you. By default, it will execute all the steps here and then generate a binary. So that's how the C programming works here. I mean, the C++ works here. Do you have any doubts? And this is the full build command. If you run this command, right, so it internally does all the stages by default. And that's why while you have a huge applications, right, the C++ or C code, building that will take some time. But once the code gets built, right, the execution is super fast. Yeah, that's all I have for the session. Maybe if you have any doubts, you can please feel free to ask me.